Alright, so section 3.5, we're going to go a little bit more in depth with linear relationships. So linear relationships are, on a graph, they're just straight lines, right? That's just what linear means. So for the first example, we have Ava has multiple coupon codes to use for discounts at an online clothing store. She's debating between using a $15 off coupon or a 20% off coupon, but is not sure which will give her the greatest discount. So the question I have is, what range of prices is each coupon best? Well, if we start out with let's say $15. So if something is worth $15 and we take $15 off, well then it's at $0, right? So it's basically free. So it's definitely better than the 20% there. So I know like the lower end of prices, the $15 off coupon is going to be better. But if we go up to like maybe let's say $1,000, if we do 20% off $1,000, we get what, $200, which is definitely going to be better than the $15 off. So I know at the higher prices, the 20% off is going to be better. But I want to know the exact range of prices, right? So what I can do is I can use equations, or I can talk about this and talk about this and find out where these two are equal to each other. So what dollar range? And the way I can do that is I could say, well, whatever my price is, I'm just going to label it X. I just subtract $15 off for a $15 coupon, right? So I could have X minus 15 for that side. And then I want to find out where those are equal, where 20% off of something is the same thing as taking $15 off. So I'm going to set this equal to, and I'm going to set it equal to, well, 20% off just means that something is 80% of that price, right? So I have 0.8x. So that's just 80% of x, is just that $20 coupon, okay? Or 20% off, rather, okay? Now all I want to do is solve for x here, right? So what I'm going to do is I'm going to subtract 0.8x on both sides. And then on the left side I'll get 0.2x minus 15 equals 0. Right? And now I can add 15 on both sides. So I'm going to continue that over here. 0.2x equals 15. And then finally, to get x by itself, I'm just going to divide by 0.2 on both sides. So 15 divided by 0.2, I believe it should be $75. So what that's saying is that at $75, you can use either coupon and you'll still get $15 off, right? But kind of how I talked about before, if it's greater than, if x is greater than $75, so I'm going to use this symbol. If x is greater than, so that's a greater than symbol, 75, then the 20% off coupon is best. If x is less than 75, then the $15 off is better. Okay? Alright. What about the next one? So when gas prices are high, consumers often shop around for the lowest price. Some gas stations offer per gallon discounts with the purchase of a car. At your local gas station, these options are available. So your first option, it's $3.65 a gallon, but with that, you have the caveat of you have to buy a car wash. So it's basically, if we look at the next one, it's 20 cents off as long as you buy the car wash. Okay? Then option 2 is just $3.85 a gallon if you don't buy the car wash. So this one says, here are two tables that calculate the price of gas per gallon. So if we look at option 1, so this is the same option up here. If we buy 0 gallons of gas, well, we just have to pay for the car wash, right? If we have 1 gallon of gas, we multiply those two together and then add 550 in, and we keep doing that all the way down, right? So our formula here, so if we don't know how many gallons, we just say G, so some variable. We don't know how many gallons we buy. Well, a formula to buy that, to find how much it actually costs, is just $3.65 multiplied by the number of gallons you buy, plus the $5.50 for the car wash. Okay? And then similarly for option 2, if you buy 0 gallons of gas, that's not going to cost you anything, right? And then as you go up, you just multiply each one. But I want to look at where they kind of cross, so where they're equal to each other. If I look on this side, it looks like for 20 gallons, this one's more expensive. The $78.50, this one's $77. If I go down to the next one, this one's still more expensive, right? But it kind of closed the gap. It's only 50 cents more expensive now. If I look at the next one, well, hold up, this one's more expensive than this one now, right? So we kind of did a flip-flop here from 25 to 30 gallons. So I know somewhere between 25 and 30 gallons, there's a break-even point, or where they're equal to each other. So kind of like the 15% off, or the $15 and the 20% off coupon are equal. Well, I know somewhere between there they're going to be equal. And I want to know exactly where they're equal at. Well, how can I do that? Well, I'm already given these two formulas, right? So I can just set them equal to each other. So let's do that. So on the next page, it says, where's the exact cutoff between fewer and more gallons? Well, we kind of already found out that it's between 25 and 30 gallons from the last page. But we want to know exactly where it's at, right? So what I can do, and it kind of gives you here where it's right in between where they're even, so 27.5 gallons. But how did they find that? Well, how to find that is you have your cost with option 1 and your cost with option 2. So if we set those equal to each other, we should get that the number of gallons has to be 27.5. Okay? So I'll do that down here. So we have 3.65 gallons plus 550 equals 385 a gallon. Okay? So we're just setting them equal to each other. Right? And now I can just solve for G, right? So let's subtract this 3.65 gallons on each side. So we'll subtract that on each side. So I end up with 550 on the left, and I end up with 0.2 G on the left. Okay? And then now I can just divide both sides by 0.2 again. And I get G, so the number of gallons, is equal to, and it should end up at 27.5. So 27.5 gallons. So at this price, both sides are equal, right? So this is known as the break-even point. But I want to know, is either one better? Like, is option 1 better than option 2 at 27.5 gallons? Well, they're the same price, but you're getting more with option 1, right? You're also getting a car wash. So I would say option 1 is better at the break-even point than option 2 because you're getting that extra car wash. Okay. All right. So let's look at the next page now. So the next page, it kind of gives more of a visual view for you. So it says a graph can also be used to solve this problem with the gas pricing options. So it says to draw the graph, we need to graph each line on the same coordinate system so that we can compare them. So I already did that on the table for you, so it's already drawn. So the one on the bottom here, the one with the squares for the dots, that's option 2. So that's without the car wash, right? And you can see that it's definitely lower at 0 gallons, right? Because you're not buying anything, you're not buying any gallons, you don't have a car wash, right? And then it slowly increases higher and higher. And you can kind of see that it eventually overtakes it, right? And it's kind of hard to see, but you see it overtakes it up here. And that break-even point is at 27.5 gallons. So the reason it overtakes it is because your gallons are more per gallon, right? The cost is more per gallon. So the more and more you go out, like if I wanted to extend this further and further out, option 2 would become even more and more expensive as we go out even further. Okay? All right, so then just the important part right here is that point right there. That's where they're exactly equal to each other. So 27.5 gallons, and that's the price for the gallons. Okay? All right, let's look at the next problem. So the next problem says, Dana and her sister Emily own a small home-based business creating gift boxes with special wrapping details on each item in a box. So if we look at two different things, so it says Emily can pack a box in 6 minutes, and Dana works faster at 4 boxes per minute, but she joins late. So she joins 20 minutes after the session has already started. Okay? So I want to know if I can write the time functions to describe each line. So I want to describe how Emily packs boxes and how Dana packs boxes. So I'm going to say the number of time it takes, so time t, and this is for Emily. Well, it takes her 6 minutes for each box, right? So the amount of time that she spends is 6 minutes per box. Okay? And then similarly, Dana, the amount of time it takes her, well, it takes her 4 minutes per box. But we also know that she starts 20 minutes late, right? So I'm going to add 20 minutes to this. Okay? So those are our time functions, right? So this is the time function for Emily. This is the time function for Dana. So B says, how much time will Emily have worked when Dana has completed as many boxes as Emily has? And how many boxes will each of them complete at that point? Well, we have these two formulas right here, right? So what if we set them equal to each other so we can find out when they have the exact same amount of boxes made? So I'm going to have 6 boxes. 6 minutes per box is equal to 4 minutes per box plus 20. Right? And then we just solve it as normal. So we're going to subtract 4b on both sides. So we get 2b equals 20. And then we'll divide by 2 on both sides. So we get b equals 10. So they'll have 10 boxes made, right? So they'll have 10 boxes made at this point, and they'll have 20 boxes total, right? So 10 and 10. But then it asks, how much time have they worked, right? Because this is the amount of boxes. So how do we find time? Well, we have formulas for time up here, right? So what if we just plug in 10 to b? And we can do it on either one and you get the same answer. I'm just going to do it on the top one because it's simpler. So the amount of time it takes is 6 times, and b is 10 in this case. So it took them 60 minutes to make 10 boxes each. So 20 boxes total. Okay? So that's how much time has elapsed when they've completed as many boxes as each other. So Dana and Emily have both completed the same amount of boxes. All right? All right. Let's look at the next one. So the next one says, Nate's wife recently had triplets. Knowing that diapers are going to be a part of their lives for a few years, he looks into options for buying them inexpensively. So the first one says, a jumbo box of a brand that he likes costs $30 in town with a 6% sales tax. So that's this column right here, column B. Okay. At another store, he can buy the same jumbo box for $26 with a 7.5% sales tax. So it's a lower cost before, but there's an increased sales tax, right, because it's in another town. And then lastly, if he buys online, he can get a jumbo box for $25 with no sales tax, but there's a flat $8.50 shipping cost if he buys one or several boxes. So he plugs all these into Excel here to find out what each one is. And we see that the first number of boxes, if you just have one, so it looks like the second store is cheaper overall if we just buy one box, right? So we want to know which option is best for how many boxes. So I'm just going to circle these for which one's best. Well, if I have one box, I see this is the lowest price. So that's the best one. Option 2 is the best one for the first set. If we have 2 boxes, it looks like the second store is still the cheapest. If we look at 3 boxes, it looks like the online store is cheaper now, right? If we look at 4 boxes, it looks like the online's cheaper again. 5 boxes, it looks like online's cheaper again. And if you keep going down, it looks like the online is cheaper all the way down. So the online is cheaper all the way down. So the question is, which option is best for how many boxes of diapers? So for 1 and 2 boxes, the second store is the best choice. The second store. Okay. And then for 3 plus boxes, so 3 or more boxes, the online store is best. Okay. So is there anything else that we can get out of this? So if we keep extending this past 22, well, we see that this is always lower than these two after 3 plus boxes, right? So it doesn't matter how many more boxes we buy, it will always be cheaper than the other 2 stores. Okay? All right, and then for my last example here. So this one says Lauren spends $140 on groceries per weekly trip on average. She's considering joining a shopping club with prices that are 20% lower than the prices at her grocery store, but the shopping club charges a $45 annual fee to join the club. It says Lauren has looked at the shopping club's inventory and finds she can't buy everything she normally buys at her grocery store. She expects that she will still need to spend $20 of the $140 each week at her grocery store if she joins the club and buys the rest of her items there. So will she save enough at the shopping club to make up the cost of the annual fee before the year is over? Or should she buy all of her items at the grocery store only? Okay, so let's kind of break that down a little bit. So I'm going to say, I'm going to look at yearly cost. Since we have this annual fee here, I'm going to look at the yearly cost of each option. So option 1's here. Option 2 is like all of that. Okay. Okay. So if we look at option 1 here, we know that her cost per week. So the cost per week for the first option is just $140 a week, right? And then after that, for her option 2, her cost per week, well, it looks like she spends $20 less, right? She spends $20 a week at a grocery store, at the regular ones, all right? So we have $20 for each week. And then we also know, so that's the first part down here. We also know that she spends the other $120 at the grocery store, but it's 20% off, right? So it's 80% of the price. So we have to add to that 0.8 times 120 per week. So that's the 20% off. And then we have to add to that $45 for the annual fee, right? So we'll just add that. So add $45. Okay? And then we can simplify this a little bit, right? So if we have 0.8 times $120, we get, this is 96W, and we're going to add to that 20W, right? So we spend about $116 each week at this place for the same groceries that we do here, plus the $45 for the annual fee. So that's our cost. Okay? So we want to know, and I'm going to make a little bit of a chart here because I think that'll be helpful. So I want to know if it's cheaper to pick this option or this option for shopping. So I'm going to make a chart here. So my chart on the left is going to be 140W, and my chart on the right is going to be 116W plus 45. And then I guess W over here. So for my first week, so week 1, it'll cost $140 for the first week here. And over here, it'll be 116 times 1 plus 45. So we'll get $161 over here, right? So for the first week, it's definitely cheaper to buy this option. But what about for week 2? Well, no, that's pretty easy. This one's going to be $280 for that week. And how much is it going to be over here? Well, 116 times 2 is 232 plus 45. We'll have 277. That's interesting because now we're actually less than the price over here, right? So for the second week, it's cheaper to do this one over here. What do you think is going to happen for the third week? So I plug in 3 for W on both sides. So 140 times 3, well, we get $420. And what about 116 times 3 plus 45? So we'll get $393 over here. So it's definitely cheaper this week as well, right? So this pattern is going to continue. It's going to be cheaper on this side than it is on this side. So after the second week, it's cheaper to pick the second option than the first option, right? So will she save enough at the shopping club to make up the cost of the annual fee before the year is over? Or should she just buy all her items at the grocery store? Well, I would say that the earlier option is better, right? So she will save enough because after the second week, she's actually spending less than she is on the first week. So I would say option 2 is better after the second week. Option 2, sorry, put the 2. Option 2 is better after the second week.